Hello everyone, my name is Ken, and today using the Aparavi Toolchain, I'm going to present a HR solution for Post-ATS resume screening. Now, as we all know, hiring for a new job is a long and cumbersome process. First, you make a job posting upon which you get hundreds of applicants. Then the applicant tracking system, better known as ATS, filters out most of these resumes. The leftovers get sent to HR. The recruiter will then screen through them all. Although ATS has filtered out a lot of the resumes, there's still a large pile left for HR. Famously, a recruiter only spends about 7 seconds on each resume. And finally, after the recruiter has selected the top few candidates, they get sent to the hiring manager who will select the ones that they like, interview them, and possibly offer them a role. Today, our solution focuses on the HR screening part of the process. Why? Because even though, as said earlier, even though ATS filters out most of the resumes, there's still a lot left. On average, HR spends 23 hours screening resumes for each hire. We're going to see if we can cut the number down a little bit. Our solution comes in two forms. Ideally, they will be used together. First is a job resume similarity scan. This will be most effective if the number of resumes left over for HR is still a very large number, in the hundreds perhaps. This is an algorithm that will give a score to each resume based on how well it matches the job description. For the technical people in the room, it uses vector embedding and cosine similarity to compute the similarity score. For example, let's say we have a candidate, his name is Jake Holloway, and our system shows that he has a score of 53%. Then there's Madison Carter with 45%, Travis McCoy with 37%. According to this algorithm, Jake Holloway is the candidate that most closely matches the job description. It is worth noting that just because the system gives it a higher score doesn't necessarily mean that Mr. Jake here is the best candidate. This algorithm is best used to trim down the number of candidates that we have to look through. Maybe we have 100 resumes, we can trim down and only take a look at the top 30, for example. It is not meant for you to pick the best candidate just based on the algorithm alone. Next is what we call a unique values of each resume. This is an algorithm which will extract the most unique keywords of each resume relative to the rest of the resumes. For example, let's say the job posting is for a data visualization engineer or data visualization consultant. We have 3 candidates. They all know how to use SQL, they all know how to use Python, they all know how to manage their stakeholders. So what set these candidates apart? Well, Mr. Jake here uses Microsoft Azure and Power BI. Ms. Madison uses AWS Athena and Amazon QuickSight, whereas Mr. Travis uses MySQL and Tableau. So from here, we can see which softwares each candidate is familiar with, and we can determine which one of these are more suitable for the role. Perhaps in our company, we use Amazon Suite of Services, in which case, Ms. Madison will be the most suitable candidate. For the technical people, we use a TF-IDF algorithm to compute this. The technical process chain is very simple. We store resumes in the folder, which I'll show in a moment. Then from the folder, we upload it to VBA via the Aparavi Toolchain. This will also vectorize the resumes for further processing. Next, we will run the Python scripts, which I'll also show in a moment, which will pre-process the text and output the 2 algorithms as we shown earlier. Lastly, it will export to CSV files for humans to take a look at. So now, let's take a look at the technical backend. This is one of the sample resumes that we use. The data is completely fictional, this person does not exist, so maybe try not to contact them. Anyways, we have 25 of these sample resumes and I put them into a folder. For this project, we use a local file system, which means that the resumes are actually on my local computer right now and it's connected to Aparavi through a local connection. This Aparavi install is also a local root. But we could have also used the AWS S3, SharePoint, Google Drive, or any of these other file storage systems that Aparavi supports. Anyways, once you uploaded them to Aparavi, we use the Aparavi Toolchain, which, as you can see, it's a very simple process. We just connect the data source into the VBA vector database. This is how it looks in a VBA cloud. Even though there's only 25 resumes, there's 49 objects because VBA has chunked them into smaller segments. The details of this is found in the VBA documentation. Anyways, once we have data in the VBA cloud, we can process them in Python. Let's take a look at the Python code. So we connected the VBA cloud in Python through Google Colab. You could also run this on a local Python install. we put a job description in. In this case, the job description that we're using is actually one of Aparavi's job postings. They are hiring for a summer intern and also associate AI developer intern. Anyways, once we have the job description, we need to embed it using the same embedding as we use for the resumes in VBA Cloud, done by Aparavi's Toolchain, which in this case was a multi-QA mini LM L6 course V1. After we have done that, we can compute the similarity score. You can see the output here, where it gives a similarity score to each resume. Let's take a look at it in Excel. This one. You can see each resume has a similarity score. In this case, resume number 3 has a higher similarity score. And it goes from around 60% to 49%. So all the candidates are roughly similar in similarity score, which makes sense given that the resumes are artificially generated. For real resumes, we will expect to see a wider variety. That's our first solution. The second solution is this one, where we filtered out the common stop words in resumes such as resume, curriculum, skills, responsible, team. Anyways, after that, we find the unique words for each resume using TF-IDF algorithm. You can see it here, but let's take a look at an Excel for an easier look. We can see, for example, where, let's see, this candidate is more known for algebra than other candidates. This one's known for code analysis. This one does benchmarking rather. This one does conversational agents, which are chatbots, of course. Now, we can go one step further, and instead of just looking at the highest TF-IDF score, we can look at the highest TI-FDS score for each term relative to the TI-FDS score for other terms. In other words, if we go one step further and find the most unique keywords for each CV. So let's take a look at what that looks like. We can see that, once again, algebra and mathematics are there for resume number 18, and we see that he has algebra 49.5 times more in his CV compared to any other candidate. This one has retrieval augmentation, probably RAG. Let's see what else we have here. This one does robotics. Let's see. This one has some relation with Intel, LLM agents. So from here, LLM system, knowledge graphs. So from here, we can see what makes each candidate stands out compared to the rest. Remember that all of these candidates already have around a 50% similarity matching score with the job description, so we know that they are all more or less qualified for the role. It's just a matter of picking which one that we want based on what sets them apart. For example, do we need a Korean native? Do we have Korean clients? Do we use Python Streamlit? This will help HR as well as hiring managers to quickly identify the candidate that they want to interview. My name is Ken. This has been my submission for the Aparavi Social Media Challenge. Thank you very much.